Good morning or good afternoon. Happy Monday. Could be whatever day you might be watching this. We're going to do grade 8, unit 1, lesson 14 today. Very important lesson. Some of you are going to see many times throughout high school too. Called alternate interior angles is the title. The learning goal, let's explore while some angles are always equal. The learning target is if I have two parallel lines cut by a transversal, I can identify alternate interior angles and use that to find missing angle measurements. So there's a fancy word there, transversal, and a fancy statement called alternate interior angles. But if you remember, guys, we've already talked about something called vertical angles. And if you remember, if I have an angle here, this angle is vertical to this one, and this one is vertical to this one. I often call them opposite angles, but if you remember, those are equal. If you know that, guys, then today's lesson is not going to be terribly difficult if you remember that. So go ahead and take a look at this warm-up. It says angle pairs. Find the measure of angle JGH. Explain or show your reasoning. JGH. First off, if you don't know how to find that angle, you're going to have difficulty. But that G means that is the vertex of the angle. It's where the angle will meet at a point. Step 2, letter B, find and label a second 30-degree angle in the diagram. Find and label an angle congruent to angle JGH. So go ahead and take a minute to try to do that on your own. You can pause this video when you're done. Go ahead and unpause it, and we'll see how you did. How many of you really paused the video? Come on now. Pause it. So this is JGH. So we're actually looking at this angle right there. What is the measure of that angle? What is the measure of that angle? What's the measure of that angle? We do know this is 30. Hopefully you're recognizing that I have a straight line here. And that means 30 plus something else makes what? A straight line. And hopefully you remember that a straight line is equal to 180 degrees. Or a straight line angle is 180 degrees. So we're essentially saying 30 plus what is 180? And if you said 150, you would be correct. So we know that that angle is 150, angle JGH. It says find and label a second 30-degree angle in the diagram. I don't know what they mean by label it, but guess what? This angle right here would be 30 because that's, remember, a vertical angle. Find and label an angle congruent to JGH. Well, I don't know how we would label it, but I guess we could call it FGI. And remember, there's a simple symbol. You could write the word angle, or you could just draw a little angle. Because you'll notice this angle here is a vertical angle to this angle here. Hopefully that rings a bell. If you can do that, then the rest of today's lesson is going to be relatively simple. But we are going to notice a little twist today. So let's go to activity 1. It's cutting parallel lines with a transversal. It says lines AC and DF are parallel. They are cut by transversal HJ. It says with your partner, but we're going to just try doing this on our own. If you want, you could sneak a peek. Although, you could call me your partner today, because I'm making this video. So, since I know this 63-degree angle, guess what? I can actually find every single other angle in this. I can find this angle. I can find this angle. I can find this angle. Well, I already know that angle. I can find this angle. I could find that angle. I could find that angle. I can find that angle. Just by knowing that 163-degree angle. Since these are parallel lines, and a transversal, guys, I guess we need to cover that first. This is a fancy word. It's just saying a transversal is saying this line right here, it's the transversal. It is transverse the parallel lines. These blue lines, hopefully you recognize. They're not blue, I'm using red apparently, because when I touch blue, it doesn't go to blue. Thank you, iPad. Those two lines are parallel, and if parallel lines are cut by a transversal, if those parallel lines are cut by a transversal, then whatever is happening down here is going to be mirrored up here. And you can actually prove that through a rotation. You could rotate this bottom image, rotate it up here, and have the identical image. So if you needed to prove that through congruence or transformation, you could literally prove that those angles, all you have to do is trace it too. If you traced this figure down here, that X, and slid it up here, you would notice you have the exact same figure. So whatever is happening down there is going to happen up there. So if you haven't already, at the very least, it says find the 7 unknown. The most obvious one that we can do, if this is 63, guess what? This one down here is 63, because those are called vertical angles. And hopefully you recognize that. Well, guess what? If I were to translate this straight up, if I took B to E, you'll notice, well, then this is also 63. If that's 63, then this is 63. So we just knocked out 3 of them. Now, we do know if this is 63, we should see a straight line. This blue line is straight, which means I have 63 plus something equals 180. So how do we do that? Well, I'm going to have to subtract 63 from each side. Now we'll get rid of that. If I subtract 63 minus 63, I'm giving you guys a sneak peek in what we're going to be doing later on this year, and that's solving 1- and 2-step equations. And so the question mark, where x would equal 180 minus 63, I believe it'll be 117 degrees. So right here is 117 degrees. If that's 117, guess what? That's also 117. If this is 117, then this is also 117. So this will be identical to that. And that the key here is that only works if lines are parallel. And if they're cut by a straight line, just a fancy word for a transversal, it's just transversal. It's just cutting parallel lines in half. And then that means you're getting 2 images, 2 identical images. And it says explain your reasoning. We could, if we wanted, add something saying maybe like parallel lines. parallel lines and transversal make identical images. Or better yet, we should say congruent. Why am I even bothering with that word? Shame on you. Congruent images. All right. And then we also have all of this. Everything we just did here is also explaining our reasoning. Numbers can also be used in our extreme. And it says, what do you notice about the angles with vertex B and the angles with vertex E? I hate to erase all that, but you can rewind and go back to that. But let's take a look here so I can see this. What do you notice about angles with vertex B? Here's vertex B. And angles with vertex E. And that should be obvious. I don't even know. This book is notorious for kind of, and maybe that's shame on me for thinking that's obvious. But what do we notice? We should notice all the angles are congruent. And we can prove that too. If you had tracing paper, you should just trace this and move it up there if you're not quite sure. And again, this only works with parallel angles. If it doesn't say it's parallel, we can't do any of this. Then we have to just go back, get out a protractor. So, using what we noticed, find the measures of 4 angles at point B in the second diagram. Lines AC and DF are parallel. So, this is very important to know that it only works if these are parallel. This line and this line are parallel, and they're being cut by a transversal. So the same thing happens. This has just been rotated around a little bit. Using what you know is find the measures of the 4 angles at point B. There's point B. Believe it or not, I can tell you what this angle is, what this angle is, what this angle is, and what that angle is. All because these are parallel lines. But the most important piece of information, go ahead and hit pause and you guys fill that out. Maybe you've already done that, but it takes a tiny bit of math. If you need to take a minute, go ahead and try that. You hit unpause when you're done. Did you really pause it? Hopefully you're getting in the habit of thinking on your own first. Got to get in that habit. If we know that this is 34 degrees, then guess what? We know that this is also 34 degrees. If we know that that's 34, we've learned that a vertical angle means this is also 34 degrees. And then hopefully we have got this ingrained in our brain that we can make a straight line, which means it's going to be 34 plus something, and that's going to equal 180 degrees. So I got to subtract 34, those are nothing. 34 minus 34 is nothing. I'm left with question mark. Equals, well, going to have to do some math. That's going to be a 6, got to borrow. I think that's 7, that's going to be a 4, 146. So that's 146. And then the opposite angle, if that's 146, then the opposite side is 146. This angle and that angle will be equal to 146. And there you have it, guys. You kind of have, I guess we haven't gotten into this main term here, alternate interior angles, but you kind of have been doing alternate interior angles without noticing it. We'll do that in just a second, I think. The next diagram resembles the first one, but the lines form slightly different angles. Find the 6 unknown angles here. You might quickly notice, wait a second, these aren't parallel. Doesn't matter, just have to do a different approach, and it's not a terribly different approach. If we know that this is 108, we can figure out the rest of these angles. We can figure out, obviously, hopefully it's obvious, that then if that's 108, then this is 108, because that's called a vertical angle. That's 108, and that's 108. So we got that one. And you can probably finish the rest. Now this is not true. You're going to notice that, oh, this must be 72 in order to make that 180. That makes this 72. Well, notice this is 63. And you probably, this is not parallel. You probably are noticing, wait, these aren't parallel lines. So we can't use that same theory, and not a big deal. It's just making sure that we recognize, hey, if they're not parallel, we can't do that. But now we've got to apply new angles for that down there. And they gave us this 63. They gave us that 63. So you can go ahead and fill out the rest of those. And when you're done, hit unpause. And I kind of answered E for you. It says, what do you notice about the angles in this diagram as compared to the earlier diagram? How are they different? How are they the same? So that's pretty self-explanatory. I'll let you go ahead and answer that. When you're done, hit unpause. Hit pause for now, and then when you're done, hit unpause. If there's time, you can come back to this. This is a good, are you ready for more? Question saying, what is this angle? Very, very doable. There's one key piece of information you need to know about a triangle. That all the angles in a triangle, the three angles in a triangle, add up to 180 degrees. So you'll be pretty easily able to find X. So go ahead and do that one. That's not. Now we're going to get into this fancy term a little bit, but you kind of already intuitively know that alternate interior angles are congruent. They're equal. They're the same measure. So it says lines L and K. Here's line L. Here's line K. They're parallel, and T is its transversal. So that's important to know that they're parallel. If it doesn't say they're parallel, we can't assume much. Point M is the midpoint of P and Q. Here's point M. Find a rigid transformation showing that angles MPA and MQB are congruent. So MPA always helps to outline that. MPA, MPA, so they're talking about that angle, this one right here. And, whoa, don't mess with me. Jeez, this thing scares me sometimes. And MQB, so MQB. It says find a rigid transformation showing the angles MQB and MPA are congruent, meaning they're the same angle. And it says that this is the midpoint right there. So that should be a big clue. What do you think the rigid transformation? How are we going to take this angle here and put it down onto this angle down here? If you took your tracing paper and held it over here and made this your center point right there, you should be able to say, hey, I can take angle MQA. I would say rotate angle MPA or MQB, doesn't matter, 180 degrees. Notice I'm not even saying clockwise or counterclockwise, because 180 degrees clockwise or counterclockwise will still put me in the exact same spot. But I do have to say my center of rotation. and be a 180 degrees around, hopefully we're saying point M. And you'll notice if I did that, if you took your tracing paper, you should try it because it's important that you recognize this. That will rotate all the way around onto that 180 degrees. And what you just did, maybe the questions are going to get into that, but you just did what are called alternate interior angles. It's a weird, fancy term, but let me show you. This is parallel line, right? And here's a parallel line. The angles that are interior, inside those parallel lines, is this angle here and this angle here. Those are the two angles that are inside that. And guess what? Alternate interior angles.
Excuse me, teachers, if we could have freshmen, sophomore, juniors, and seniors report to the gym, and please set in your grade on the bleachers, starting with the freshmen.
So it says alternate interior angles are congruent. So there's this right here, and there's this right here. Those are interior and they're alternate. One is the alternate side of the others. And if you aren't noticing already, you just proved that one can go exactly, they're congruent, they're equal, they're equivalent, they're the exact same thing. So the fancy term for this is alternate interior angles are congruent. And you can prove that with rigid transformations, but you'll also notice in those last pictures, hey, if this was 30 degrees, guess what? This was 30, which means this is 30, this is 30, that's 150, that's 150, that's 150. And technically speaking, you could argue that this is an alternate interior to that, and that's 150, and that's 150. So it's a fancy, fancy word. Whether or not you remember alternate interiors, what does that even, what? That's irrelevant as long as you understand that, hey, if I know lines are parallel and they're cut by another line, I can tell you all the angles for both parallel lines and both whatever, line angles, whatever I'm trying, you know what I'm saying. So, fancy term for just saying, hey, if I know what one angle is, I can figure out the others. So from now on, because you're going to see some problems, they're going to give you, oftentimes, hey, they're going to say, this angle is 30. Then what is this angle? Well, alternate interior angles are equal. And if you don't remember that, well, you just need to know if that's 30, well, then this is 30, which means that's 30. So it's just a very long, complicated process, but it's just trying to say, hey, if you know what that angle is, you know what the other one is, if it says they're parallel and cut by a transversal. So let's look at problem 2. In this picture, lines L and K are no longer parallel. M is the midpoint. Does your argument in the earlier problem apply to this situation? What's it asking? It's saying, is this angle, if they're not parallel, is this angle going to be equal to that angle? Are they going to be equal to one another? You can say yes or no and put your answer there. And when you're done, here's just a quick summary that explains everything we just did. Notice they're doing 180 degrees, subtracting some angles to get the missing angle. Just like that right there. And that's about it, guys. Lesson 14. Yeah. lesson 14 practice problems. It's what you can do right now. Use the diagram to find the measure of each angle. ABC, so write an answer here. What's the measure of ABC? What's the measure of EBD? What's the measure of ABE? And knowing what we know, this is all just vertical angles here. You should be able to do that. Problem 2, lines K and L are parallel, and the measure of ABC is 19 degrees. Explain why ECF is also 19 degrees. If you get stuck, consider translating line L by moving B to C. So we kind of did an explanation a little bit in the previous problem. So write down why ECF, this angle right here, they said that's 19 degrees. Explain why the measure of angle is 19 degrees when they told us that ABC, there's line, that's angle ABC. They said that's also 19 degrees. They said that right here. So why is that equal to that? And it gives us a big clue. If you get stuck, consider explaining a rigid transformation. And then it says, what is the measure of angle BCD? The most difficult part in these, hopefully it's not that hard, is just identifying what angle are they saying. They're saying BCD. What's that one? And then explain. So we just give a short explanation of why that works. And if you need a clue on what the explanation is, you can say this. You can say that. That's as good as explanation as anything. Problem 3, the diagram. Hopefully you're pausing. You don't have to go at my pace. The diagram shows 3 lines with some marked angle measures. Find the missing angles. That's just like a problem we just did. Notice these aren't parallel, not a big deal. Means you just have to treat this one separate from this one, unlike the previous problem, unlike if they're parallel. But they do give us 2 angles, so very doable. Problem 4, lines S and T are parallel. Find the value of X. This line's going everywhere, and they're trying to confuse you with some other lines. But you need to make sure you can identify the 2 lines that are parallel. They're saying this one and that one. Those 2 are parallel. Find the value of X. What is going to be this angle here? That's the question. This one's a little trickier. I will give you a clue here. There is a triangle right here. This triangle, I do know what 2 of those angles are. One of them is 90, and the other is 40. And as I said earlier, all the angles in a triangle, all angles inside a triangle add up to 180 degrees. So once you can figure that out, you'll know what X is because of vertical angles. Problem 5, the 2 figures are scaled copies of each other. What's the scale factor that takes figure 1? This is going a little bit back to 7th grade math. How do I get from figure 1 to figure 2? And then how do I get from figure 2 to figure 1? And if you remember, you don't have to pay attention to diagonals. You can pay attention to any corresponding distance. For example, the distance from here to here, you could count that. You could also count the distance from here to here if you'd rather do that. But it has to be a corresponding side. So if you count from here to here, then you have to count from here to here. And if you thought the scale factor, oh, I have to take figure 1 and multiply it by 4 to go backwards, means times 1, 4. We don't say divide by 4. We don't say divide by 4 here if we thought it was 4. We would say what? Dividing by 4 is the same as keep, we keep whatever this number is. We change divide to multiply and we flip. That's what we would say if we thought the answer was 4, but hopefully you don't think the answer is 4. That's about all she wrote, guys. We'll call it good for now. I'll see you guys tomorrow for lesson 15. Peace.